In this lesson, I'm going to show you how to find surface area, but this time, instead of drawing out nets for every surface area, I'm going to show you how to use formulas. So I'm going to go shape by shape. I'm going to start with rectangular prisms. So if you recall when I was showing you the nets, I told you that every rectangular prism can be unfolded into 6 rectangles. So there's 6 sides, and each of those sides has another side that's exactly the same. So if we look at this rectangle, for example, we have the front here, that's the length times the height, and the back of this rectangular prism would be exactly the same. We then have the top and the bottom, that would be the length times the width, and those are exactly the same. And we have the side, which is the width times the height, and it's exactly the same as the other side. So in our formula, we basically have the length times the width, which in this case is the bottom, plus the length times the height, which is the front and the back, or sorry, the front or the back, and the width times the height, which is a side. And we have 2 of each of those. So we're going to do 2 times the length times the width, plus the length times the height, plus the width times the height. So the most important thing when you're using formulas, if you want to just use the formula as is that in the diagram as given, you want to label all of your sides. If you label all of your sides, L, W, H, and then there's some other variables we'll use in other shapes, then you can just plug in those values. So if we look at this first example, I'm going to keep the formula there. We have a storage container that's 45 feet long, 9.5 feet wide, and 8 feet tall. So I label all the sides, and then I have that this is the length, this is the width, and this is the height. So once I know what all the sides are, I can just plug those values into my formula. So the surface area of this shape is going to be 2 times length times width, so 45 times 9.5, plus the length times the height, which is 45 times 8, plus the width times the height, so 9.5 times 8. So basically what formulas do is they take all the work of deconstructing the net and they just simplify it for you. And does it kind of all in one step. So it's just another way. If you prefer to break down a shape into all of its components, that is totally fine. You'll also be able to calculate the surface area in that way. So this is 1,727, and this is in square feet. So that's a rectangular prism. We go to the next page, we've got triangular prisms. So you'll remember here that we've got 3 sides that are rectangles, as well as a front and a back that are triangles. So when we're doing a triangular prism, the formula is basically equal to the length times the width, and this in this case is labeled as base, but that's the width there, plus the width times the height. Now what the formula does here is, if you recall in the last lesson I told you how to find the area of a triangle. You do the base times the height and you divide it by 2, but then there's 2 triangles, so you times it by 2. The formula gets rid of the dividing by 2 and timesing by 2 because those just cancel one another out. So the formula has simplified that for you. And then we have 2 times the length times the slant. So we need to know the slant, and that's the sides of the triangle, because that will be equal to the width of the rectangles on the side. So again, most important thing to do first is to label all of your sides with the proper letters, and then you can plug them into the formula. So Megan is building a greenhouse. Determine the surface area of this triangular prism. So in here we have the base and the length, or the width and the length, whatever you want to call them. The formula uses width, so I'm going to use width and the length. Then we have the height, which probably would normally be a dotted line. That might just be a protein there. So this is going to be the height, 3 meters, and 3.6 will be the slant. So if I plug that into the formula, I get the length, so 6, I should say surface area equals 6 times 4. Essentially, that's the area of the base that's sitting on the ground, plus the width times the height, 4 times 3, which is the triangle. And then remember, we canceled out that dividing by 2 because there's 2 triangles, plus 2 times the length times the slant. So when we do all of that, get an area of 79.2 meters squared. So you can see it's a lot faster to use the formula than it is to actually deconstruct the shape. The tricky part is just making sure that you label all the sides properly before plugging them into the formula, because if you don't, you're going to run into some errors. Now, part B says, what is the exposed surface of the greenhouse? So what this question means is, what are the parts of the greenhouse that are actually exposed to the sun or the air, or whatever you want to think of it? So what we basically want to do is we want to remove the bottom. So we want to remove the area of the bottom, or the part that's on the ground. So if you go back to your formula, what you'll notice is that the bottom here was 6 by 4. So it's essentially this part of the formula. So we can remove that part. So it's either one of 2 things you can do. One is, if you look up here, you'll see that 6 times 4 is 24. So we can just subtract. So I think I'm just going to do that. The area was 79.2. We're just going to remove 6 by 4 at the bottom, which is 24. So 72.9 minus 24 leaves us 79.2 minus 24 leaves us with 55.2 meters squared. So that 6 by 4 is the length times the width, which was on the bottom of our triangular prism. On the next page, we're going to talk about pyramids. Remember, a pyramid, and this is a square-based pyramid, we can do the base squared and then add the 4 triangles. So the triangles are base times height and divided by 2. This formula just sort of writes it in a different way. It writes it as base times the slant height, because now we call these a slant now because in a pyramid they're folded up and inward. But this is basically the same as base times height divided by 2 of those triangles. And there's 4 of them, so we multiply by 4 because there's 1, 2, and then 3, 4 on each side. So if we look at our example here, we have a base that's 6, so it's 6 squared. I should label that over here. So this is the base. And then this 5 is the slant height, or the height of the triangle. So then we're going to add plus 4 times, and you can write it either way. I'm going to write it how it was. No, I lied. I'm going to write it as base times height, so 6 times 5 over 2. You just want to be careful when you put this into your calculator that you use your brackets appropriately, so I'm going to show you how to do that. So when I type this in, I'm going to do 6 squared plus 4 times, and 6 times 5 divided by 2, all in a bracket, equals. So that means the area of this is 96, and we are in square feet. So like I said, this equation writes it as 1/2 times base times the slant. You can also do it base times height divided by 2. Those mean the same thing. On to our cylinder. So in our cylinder here, basically what we've got is we have 2 times pi r squared. Pi r squared represents the area of a circle, and there's 2 circles, and then plus 2 pi r h. This 2 pi r represents the circumference of our circle. So remember when we unfolded this, we had a rectangle where the length of the rectangle was the circumference times the height. So that's how this equation is built up. Now, it's really quite nice when you use this formula. It takes away a lot of the extra steps of breaking down your circles and rectangle. So here we have a height of 5 and a radius. Oh, sorry, this is showing a diameter. So the diameter is 4. So this is the diameter. But in our equation we need radius, so I'm just going to divide that by 2. So the radius is 2. So the height is 5 and the radius is 2. So when I go to put this in my formula, all you're going to do is just 2 times pi times the radius squared plus 2 times pi times the radius times the height. All that into the calculator. 2 times pi times 2 squared plus 2 times 5 times 2 times 5. 87.96, and it's feet, so square feet. And we've got 2 more shapes. The next one we're going to do is a cone. So we didn't look at the net of a cone. A cone actually gives you a circle and then sort of a rounded triangle. So the formula for this is pi r squared, which represents the area of the circle, and then pi times r, the radius, times the slant height gives you the area of this piece that wraps around the circle. So if we look at this example here, it shows us that Kara is designing a tent. The tent design has a base diameter of 2.4, so that's the diameter across the bottom, and a height, so straight from the bottom to the top, of 2 meters. Notice that's the height of the cone, not the slant height. I should call it S. So the slant height would be this height here, which you'll notice is what we need in the formula. So the first question asks you to find that slant height. So you're going to use good old trigonometry to find this. So if you notice in a cone here, it's kind of hard to see in this picture, especially with my bad lighting, but we actually have a triangle here, and we know 2 of the dimensions. I'm just going to draw this over here. We know the height of this triangle is 2, and the base, you see the diameter here is 2.4. That means the radius is half of this, divided by 2. So 1.2 meters be the radius, and that is equal to this half of the triangle. I extended those lines there. So this is 1.2. Now if you think way back to how we solve for this unknown to get this slant height, we can use the Pythagorean theorem. So the Pythagorean theorem states that side squared plus the side squared will be equal to the hypotenuse squared. So 1.2 squared plus 2 squared will be equal to the slant squared. So remember that formula is a squared plus b squared equals c squared. That's the Pythagorean theorem. So 1.2 squared is 2 squared is 5.44. That gives us the slant squared, but then in order to solve for just s, I need to take the square root. So the square root is 2.33. So that's the slant. I'm just going to write that over here. So if I then wanted to find the surface area of the curved surface, in our formula, this represents the area of the circle. So this is the circle. And then this is the curved, we call it the curved surface. To call it. It's kind of a curved triangle sort of shape. So the curved surface, the area of that is pi times r times s. So in this case, that's pi times the radius times the slant, which was what we just found, 2.33. So pi times 1.2 times 2.33, which is 8.78 meters squared. And the area of the base, so this is kind of breaking it up for you like next. The area of the base, well, the base is just a circle. So the area of the base is pi r squared, or in this case, pi times 1.2 squared. Now, normally in a question, if it doesn't break it down into asking you all of these separate things, you don't have to break it down. You could just put all of your information into your formula. But this question specifically asked you to break it all down into the parts. And then the last one is just asking you the total. So we have the area of the curved surface and then the area of the bottom. So I'm just going to add those together to get the total, which is 13.3 meters squared. And last, but definitely not least, is the sphere. So a sphere, its formula is really simple. It's just 4 times pi times the radius squared. So here we've got painters that have been hired to paint a water storage tank that is in the shape of a sphere. The tank has a diameter of 22 meters. What is the outer surface of the sphere? So for our sphere, the surface area is equal to 4 times pi times the radius squared. Now in our question here, we have a diameter of 22, so that means we just need to divide that by 2, 11, and that is our radius. So then in our question, we're just going to do 4 times pi times the radius squared. 4 times pi times 11 squared. We get 1,520.53 meters squared. That's how we find the surface area of a sphere.